There's all of these phenomenal technologies in the battery space that have been around for a long time. But one of the hidden challenges is that all of these unique chemistries speak almost a unique language of how they need to integrate. So we took the approach of how do you teach power to think?
Number one, we have David over here, our new, as you call them, our new smug robot.
AI techniques have improved enough that we can start to do manipulation, have the robot touch the world, move objects around.
Battery technology and power is going to be one of the most fundamental needs and growth areas over the next few decades. As we're putting all of these more complex, high-thinking systems online, the systems that power them have to keep up with that demand that's coming. When I used to work at Northrop Aerospace, we used to help integrate and build all these battery systems for the DoD, from airspace, underwater, US Special Operations. Even in my spare time, I worked for the San Diego Zoo as an engineer building battery systems for polar bears up near the North Pole. So I've done battery technologies, anything and everything and in between. And so what happens is, as these new technologies come online, they force products to have to completely redesign to adopt them. And so instead of betting on one singular chemistry or one singular technology, we set out to build a universal platform, this kind of universal operating system. So one, any battery technology can connect to any product, and any product can adopt any battery chemistry and technology on Earth. So a great example in robotics was a system we built for the Robotics and AI Institute in Boston Dynamics. They had a need for incredibly high power and a very, very, very small form factor.
Space and weight were a huge concern. They didn't want to increase their weight of the battery pack by more than 1 kilogram.
They were hitting the limitations of a current lithium-ion chemistry and asked us to say, hey, is there any way we can adopt this lithium titanate chemistry, which will, one, increase our total power, it will decrease our charge time, and will give our robot a higher capability.
Yeah, start off at 400, and then we'll ramp up from there.
Part of the fun of these projects is we get to see how far can these technologies go? How hard can we push them? Batteries are very complex, and so we needed the best folks in power electronics, embedded software, classic computer science, electrical engineering, all to come together to make this type of embedded battery operating system seamless, functional, high performance, quality, and reliable. Altium, as that collaborative tool, helps all those teams centralize into kind of one area where they can turn that fundamental engineering process into reality.
We've been using Onshape for our 3D modeling and CAD, which conveniently has PCB Studio, an Altium plugin that has enabled us to pull and push boards for the integration of those boards into assemblies, the modification of those boards, and pushing back to Altium 365 for the EEs and PCB layout guys to make sure that what we want or need is in line with what they want and need.
Things can be lost in communication very easily, and Altium is a very good way to keep those things from happening.
It's a really intricate dance between software and electronics, obviously. And obviously when you're in development, there's just so many changes electrically that it's hard to have a continuous conversation with the electrical team regarding anything that they've changed on their end. So having Altium definitely helps that information flow. I can just go ahead and go on Altium and just look at what's going on.
It's also useful to see how many comments are made and which ones have been completed or not completed. It's very helpful to not allow things to slip through the cracks.
And then mark as resolved when done. So yeah, having this comment tools just kind of reduces complexity with like, oh, this task needs to be created in Jira or some other tracking software. If it's directly in Altium, I can use this as my reference for tasks to be able to do on individual projects.
One of the features that has been most beneficial as a CEO is in the viewer, I can understand where designs sit in the process. and make sure that we have the right team and resources and everything in place to make sure that we can hit our development timelines.
The biggest challenges with procurement is supply chain and availability. Inventory, especially as of late, is just fluctuating pretty heavily. Getting a heads up before we send these files off to the fab and assembly shop, we can actually get insight, what is available right now.
Did you have the bigger profile?
Yeah, I think so, yeah.
We have a 208.
Previously, their battery pack, could only do around 3.7, 3.5 kilowatts of max power. Now with this pack that we've delivered, which can deliver ultimately just over 11 kilowatts, they're actually gonna have to redesign parts of their robot to be able to actually take advantage of that additional power.
Higher power up to around 11 kilowatts and spread out over a longer time duration.
We built a custom system for them that nearly quadrupled or 4x'd the total increase in power they could get, and their charge time went around from a few hours to down to about 7 minutes.
You guys ready to run it?
Let's do it.
Yep. 3, 2, 1, go.
We didn't think pulling 300 amps out of a 5.5 amp hour cell was remotely possible when we started. And now we're wondering what world records could we set because of how powerful this thing is. The saying hardware is hard is true, but we did not get to the moon by having already been there. It takes a lot of fidelity to solve these big challenging problems, but there's nothing more fun. The intersection of hardware and software is a really fun place to be because you get to build things that fundamentally transform people's business and people's lives.